Exercise 2.5, problem 12, solution. If S1, S2 and S3 are the sum of first n, 2n and 3n terms of the geometric series, prove S1 into S3 minus S2 equal to S2 minus S1 the whole square. It's a little complicated problem, so we will go straight away into solution. I will not be doing any discussion. Okay, after following it, you can do it on your own one more time. So, given that S1, S2, S3 are the sum of first n, 2n and 3n terms of the geometric series. So let A be the first term and R be the common ratio. Okay. Okay. It's a common ratio. Okay. Now sum of n terms is Sn given by A into R to the power of n minus 1 divided by 1 minus R minus 1. And we have to be very careful. What it means is R to the power of number of terms, where n is number of terms. Okay, so for this case it will be R to the power of n. For this case it will be, because there are 2n terms, so it will be R to the power of 2n. For this case this will be R to the power of 3n. Okay, that's the point we have to note down. So S1 will be A into R to the power of n minus 1 by R minus 1. For 2n terms, it will become R to the power of 2n, right? R to the power of number of terms, because it is 2n. So S2 will be R to the power of 2n. Similarly, S3, which is 3n terms, it will be A into R to the power of 3n minus 1 by R minus 1. Now we need to prove that S1 into S3 minus 2, S2 equal to S2 minus S1 the whole square. So let's take the LHS. So let's substitute S1, S2 and S3 in the LHS. We have S1, S2 and S3. Simplify it. Substitute and simplify. So what will happen when you substitute S1? S1 is A into R to the power of n minus 1 by R minus 1. Now it is inside bracket is S3 minus S2. Open a bracket. Okay. And what is S3? S3 is A into R to the power of 3n minus 1 by R minus 1. A into R to the power of 3n minus 1 by R minus 1 minus S2, which is A into R to the power of 2n minus 1 by R minus 1. Now if you see, A is common and R minus 1 is common, right? So you can take A out. So when you take A out, what will happen? You already have on A. So A into A will become A square. Similarly, you already have on R minus 1. So you are taking one more R minus 1. So it will become R minus 1 the whole square. So this will become A into A square divided by R minus 1 the whole square into R to the power of n minus 1, which will come here. And inside the bracket, this we have taken out, this we have taken out. So it will become R to the power of 3n minus 1. Similarly, this we have taken out, this we have taken out. This will be minus, open a bracket, R to the power of 2n minus 1. Now if you open this bracket, what will happen? This will be R to the power of 3n minus 1 minus R to the power of 2n. This will become minus of minus plus 1. So this minus 1 and this plus 1 will get cancelled in the next step. Okay, and that is, so when you open the bracket, we got this A square R minus 1 the whole square R to the power of n minus 1 and R to the power of 3n minus 1 minus R to the power of n, and this minus of minus, which I explained earlier, became plus 1. So this will cancel. So you will get the final expression as A square by R minus 1 the whole square divided by R into R to the power of n minus 1, and open a bracket. One more inside the bracket is R to the power of 3n minus R to the power of 2n. Again, you can take, what can you take? You can take R to the power of 2n commonly out from these two. Okay. So A square minus R minus 1 the whole square will come as it is. R to the power of n minus 1 also comes here as it is. Right? When you take R to the power of 2n, so that will come out. What will be left out? When you take R to the power of 2n, it will be left with R to the power of n. And when you take R to the power of 2n out of this, 1 will be left out. So this will be R to the power of n minus 1. Now you see, this and this is the same, right? So this will be A square by R minus 1 the whole square and R to the power of n minus 1 whole square if you combine these two. and r to the power of 2n will be left out. That you can write it here. So that is what we have done here. So the final expression is a square r to the power of 2n. So this comes here, and this 2 is clubbed together, r to the power of n minus 1 the whole square, and this is as it is. We are bringing it r minus 1 the whole square. So this is the final expression. Only this bit is little difficult to understand. So r to the power of 3n, you can write it as, so maybe I should have written it. It's very difficult to write. Okay, let me just pause it and okay, I've made the correction here. I've added one more step here. So basically r to the power of 3n can be written as r to the power of 2n into r to the power of n. Am I right? A to the power of m into a to the power of n is a to the power of m plus n. So r to the power of 2n into r to the power of n is r to the power of 2n plus n, that is 3n. So this can be written as this. So in which case r to the power of 2n is common, right, between this and this. So that is what is taken out here. So after you take out, when you take out r to the power of n, what is left out is r to the power of n, right? And here, since you are taking r to the power of 2n commonly out, it will become 1 is only left out. Okay, so I hope this explains that step. Now this is your final step. Now next we have to go for your RHS. What is RHS? S2 minus S1 the whole square. What is S2? We know a into r to the power of 2n minus 1 by r minus 1, and S1 is a into r to the power of n minus 1 by r minus 1 the whole square. Again, if you see, a is common, okay, between these two, and r minus 1 is common. So you can take all these things out of the bracket. So when you take out, this will become a square because this is whole square, right? Similarly, this will become r minus 1 the whole square. So it will become a square by r minus 1 the whole square. And what is left out? R to the power of 2n minus 1 and r to the power of n minus 1. Now remove this bracket. So this will be a square by r minus 1 the whole square. That will remain as it is. When you open the bracket, this will be r to the power of 2n minus 1 minus r to the power of n plus 1 whole square. So what will happen? This and this will cancel. So you will get a square by r minus 1 the whole square as it is, and this will be r to the power of 2n minus r to the power of n the whole square. Again, using the same principle, r to the power of 2n is r to the power of n into r to the power of n, right? A to the power of m, r to the power of 2n is r to the power of n into r to the power of n. So between these two, you can take r to the power of n commonly out. So what are we doing? We are taking r to the power of n commonly out. So this will become, what is left will be r to the power of n minus 1 the whole square. So this you can bring it out. When you bring it out, this will become r to the power of 2n, right? Because this is whole square. So a square into r to the power of 2n divided by r minus 1 the whole square. And this part will be left inside r to the power of n minus 1 the whole square. Okay, now you can rewrite. If you look at this, this and this, it is equal. A square is there. R minus 1 the whole square is there. R to the power of 2n, it is here. R to the power of n minus 1 the whole square, it is also here. So equation 3, and as per equation 3 and 4, the LHS and RHS. This came from RHS. This came from LHS. Since both are same, S1 into S3 minus S2 will be equal to S2 minus S1 the whole square. I guess this is the only difficult part. Okay. Again, r to the power of 2, see, r to the power of 3n is r to the power of 2n minus r to the power of n, right? Similarly, r to the power of 2n can be written as r to the power of n into r to the power of n. Right? Or maybe I'll write that here. Just 1 second. No? Okay, so this is what I've done. R to the power of 2n can be written as r to the power of n into r to the power of n, right? A to the power of m into a to the power of n is a to the power of m plus n. So n plus n is 2n. So this r to the power of 2n can be written as r to the power of n into r to the power of n, right? Then what will happen? R to the power of n is there. So you are taking one r to the power of n commonly out. So this becomes, once you take one r to the power of n, left out is r to the power of n. It is here. For this one, if you take r to the power of n, 1 is only be left out. So that is why you are getting it as r to the power of n minus 1. Now you apply, when you take the bracket out, so what will happen? This will become r to the power of n whole square, that is r to the power of 2n, and this will become r to the power of n minus 1 the whole square. Okay, so I hope I made it clear. Please go through this one more time, it will become clear. Thanks for watching this video.